So hello everyone. So my name is Juntao Yu, and today I'm going to talk about like the Anaphora resolutions. So which beyond the OntoNotes. So basically, my work on the Anaphora resolution. During the project, I mainly work like the two different directions. So the first direction is Anaphora resolution. So which I trying to come up with like the different systems that can resolve like beyond the normal coreference chains. So
on Zoom, we get in presentation mode.
So you cannot see?
We got
instead of seeing just the slide, we see.
I don't know if you do that.
Oh, that's really odd.
So we basically see.
Okay.
You see, we saw.
Yeah. So I can.
Yeah, Zoom, you can choose which screen to share. You can share a different screen on Zoom.
All right, so I just change it, or maybe I can.
Displays there.
Where it is? So how can I switch the swap displays?
I don't know. Let's see if it works. Yes, now we can see the slides.
That's really odd. So can I just?
So now on Zoom we see things on the screen here.
You probably want to start sharing on Zoom and then choose a different screen to share.
Okay, so maybe just a moment. So let me use this.
Sorry.
Let me use this one.
Yeah, that works. Yeah.
So this one better, right? So
yeah, we can see.
So I guess both can see now. That's good. So basically, I worked on two different directions.
Now on Zoom we see. Now it's good there.
Oh no! So just a moment. Let me change another one.
You were very still.
Yeah, that's really weird. Okay.
Perfect.
Both correct now. All right. Yeah, start again. Basically, I work on two different directions. So the first direction is for Anaphora resolution, which I come up with like the different systems trying to resolve like the, anaphoric relations beyond the just a single antecedent. So basically what we did is like we have systems trying to resolve the singleton clusters, non-reference, as well as bridging reference and split-antecedent plurals as well. So I also did like collaborated in the other works such as release the corpus and also with the MPA and so on. And another line of work, what I did is kind of like a side project is mostly focused on the name entity recognition or the mention detector side.
Most spectacularly successful.
Yeah. So so I did like mainly two works here. So first we come up with a neural mention detector, and as well as we come up with another state-of-the-art the name entity recognition system, which based on the dependency parsing architectures. So this is, although it's a side project, but it got quite some citations as well.
Yes, the lesson is ignore anything else. Focus on name entity recognition.
Yeah, I guess a lot of people. Yeah, a lot of people researching this area. So, so in today's talk, I will mainly focus on my Anaphora resolution side of the work. So basically, I will briefly introduce four of my recent works. The Coreference resolution performance on the OntoNote has been dramatically improved in recent years due to the introduction of the neural network towards the Coreference system, and as well as being pushed by the like the Elmos and BERT, those contextual word embeddings, especially like the span BERT and so on. So it achieved a quite large improvement. However, the OntoNote corpus it's limited in a way that so it's only annotated mostly annotated single antecedent anaphoras, and not a lot of like the important aspect of the anaphoric relations is not annotated, such as singletons, non-referring expressions, split antecedent, bridgings, discourse access, and so on. My first work is we introduced a class ranking system to resolving like a few of the problems. which include the singleton antecedent anaphoras and single antecedent anaphoras, singletons, and non-referring expressions. So besides to resolve those three different problems, we also introduce a class ranking system instead of like the normal mention ranking plus system, which is the main system used for the OntoNote. So the reason we choose a cluster ranking system is, first of all, it's more linguistically more appealing, and also it's simpler in terms of the parameters. So we use only half of the parameters when compared to a mention ranking plus system. Also it's more flexible to handle the mentions, so we can do the pre-filtering and post-filtering and so on for the non-referring expressions. And as well as we can also try to explore more rich cluster level features. And also it supports some more advanced search algorithms such as the bin search. So we first, for this system, we first use a mention representation, which is similar to the Leotard 2018 system. So the main difference is that we use the BERT embeddings instead of the MN they used. And after we have those mentions, we also select 0.4 mention per token. And of those candidate mentions, we instead of doing the mention ranking, we attach the mentions directly to the clusters progressively. So by doing this, we need to create cluster representations. Basically, what we did is we use a mention representation together with some position embeddings, a trend position embeddings, and using a self-attention to create the cluster representations. So let the system learn which mention is more important in the clusters. And we also find the cluster histories is very helpful in terms of the performance. So by cluster history, we mean that so we keep all the like partial clusters formed, such as like the Stephen Jobs clusters. So we have the Stephen Jobs here, and then Stephen Jobs here and Steve, and so on. So we keep all the forms of the cluster histories. So it gives us like more chances to select the kind of like the right clusters. Other than that, so we also need trying to handling the singletons and the non-reference. So for this, we introduce like 3 different scaling functions. So by distinguish the discourse new and the non-referring, we naturally solve the singleton problems. And then for the non-referring, we have a different like scores for that. And also we use a different like the filtering process for the non-referring expressions. So we first tested on the ARRAU corpus. So as we can see, so we have the different mechanisms for the non-reference, and we compare it to the rule-based system, the Stanford deterministic system, which uses the gold mentions, and our system trained on the predict mentions, not trained on predict, trained on the gold, but did the predict mentions still have a much better result when compared to the like the rule-based system previously. We also report like the non-referring, like the F1 scores. As we can say, the system did exceptionally good on the expletives, which gives you like 100% recall and F1 of 97% nearly. So after that, we also tested our systems on the OntoNote corpus. Although the system is not designed for the OntoNote, it's still performing quite well on the OntoNote as well. As we can say, so it's only lower than the like the BERT fine-tuning system or the span BERT systems. So this comes to the my second topic, so which is we're trying to dealing with the split-antecedent anaphoras. So by the split-antecedent plurals, we mean that we have those plural mentions such as they. So sometimes it can be a single antecedent if the antecedent is like the case is like the Jones or the John and Mary. So they're grouped together. So you can use a one mentions to mark them. So this will form like a single antecedent. But some of the cases, like the mentions are separated. So like the case here, John met Mary in the park, they had a good chat. So John and Mary are separate. So this is a split antecedent. But this is also not restricted to just the names. We can also have like the other nouns like the green, blue, and both colors and so on. So the works on the split antecedent plurals are quite limited. So the main challenge is the under-resource, as mentioned before. So we only have a very small number of like the Anaphoras available. So what we did is we trying to find the auxiliary corpus, try to doing a transfer learnings to use representations learned from the other related resources, and then to improve the performance on the split antecedent Anaphora. So what we did is we like found in total like the 4 different corpora. So the first 2 is from the perspective corpus. So the PD silver means we use like the labels generated by the MPA, and the PD crowd is we simply we use more like the row annotations, so which is more noisy. And the other 2 is element of bridging Anaphora relationships and as well as a single coreference. So the single coreference it's much larger, and both of those 2 annotations are from the ARRAU corpus. And we also tried the different training strategies to say which one is better suited for the different auxiliary corpus. So the combination, the first training strategy combination, concatenate is just simply put together like the auxiliary corpus and the main corpus. And the pre-training means we first train the system on the auxiliary corpus and then fine-tune it on the main corpus. And for the annealing, I mean the approach which we introduced here is basically we progressively towards from the auxiliary corpus towards the main corpus. So initially we train 100% on the auxiliary corpus, and then in the end of the work we only training on the main corpus. So we're trying to select the best of the training strategies for the different corpora. As we can see here, for the PD silver, the concatenation works best, and for the second, the PD crowd, we found that pre-training and also element of the pre-training works best. But for the single coreference, we found like the anneal method works much better than all the other like the methods. And after that, so we tested on the test set. We compare it with some naive baselines, use the rule-based, use some rules, use like the recent 2 to 5 like the entities or the random selections. We also have a neural baselines, which basically train only on the like the split antecedent part of the corpus. And as we can see, so the transfer learning does improve a lot of like the performance both on the lenient and strict evaluations. So here the lenient evaluation means that we give partial graded, and for the strict means like all the antecedent need to be selected correctly for split antecedent Anaphora. And then when we combine the different corpora, we again get a little bit more improvement as well. So inspired by like the previous 2 works, because we find that actually the single antecedent helps most for the split antecedent Anaphora. So that's why we're trying to go 1 step further to actually doing the split antecedent and the single antecedent together, use our class ranking system. So basically what we did is we introduced additional like the scoring functions for split antecedent, and kind of like use it's slightly like a multitask learning kind of approach. So the split antecedent part of the system shares like the most of the network with a single antecedent, and just the last part, the classification part is different. we also share the same like the predict dimension as well. So in that way, so this system actually doing the split antecedent in a predict dimension setting. So we did two different training strategies. So the pre-trained ones means, so we first train the single antecedent part of the system. After training, we fix the system like the parameters and only like train the like the last classifiers for the split antecedent. So by doing this, we can kind of like separate the single antecedent and the split antecedent part to keep like the higher performance of the single antecedent. And the second things we tried is we trying to use a joint loss to train the single antecedent and the split antecedent together using this joint loss. And as we can see, so we tested on the ARRAU IST, and as we can see here, the joint approach and the pre-trained approach has a quite similar like performance in terms of like the performance and the split antecedent part. But on the single antecedent part, actually the pre-trained is still slightly better. So that's why we later on we mostly use the pre-trained versions of the system because in that way we can separately like improve the performance on the single antecedent or the number of frames without affect much on the split antecedent. And also we noticed that so there is no scores that can like evaluate both layer metrics trying to also score the split antecedent. Trying to score also the split antecedent part of the output. So basically, what we did is we give the partial scores for the split antecedent part of the system output, and also we introduce important factors for the split antecedent part of the predictions because the split antecedent is much harder than the single antecedent. So we are thinking if we give it need to be give more important factors. So let's briefly take a look at, so this is the output. So as we can see, although you can see like here, when we give the importance to the split antecedent, only one importance, we got quite close like the F1 scores. This is mainly because like all the system use the same predictions for the single antecedent. It's all from our class ranking system. And the only difference is from the predictions of the split antecedent part. And the split antecedent is it's relatively small part of the entire corpus. But if we increase the importance of the split antecedent part, as we can see, the difference become much more noticeable. Okay, so this comes to the last piece of work that we did on the bridging reference. So the bridging reference is another kind of like the the anaphoric interpretations, which is slightly more explored than the plurals. So it's kind of like associative relations between dimensions. So like in the example here, so we can find the Coreference, which is a Bakersfield supermarket, the business and it. But we also have the bridging like relations such as the customer, which is the customer of the Bakersfield supermarket. So when we're doing like this bridging reference, so we are dealing with two challenges. So the first challenge is like we have the different annotation schemes for the different systems. For different corpora. Majorly we have two different like kind of like the annotation schemes. So the first one is only annotate like the bridging based on the relation nouns, which basically means here, like the example here, the door need to be know when like the story it is. The other one is like more general bridgings, so it it can stand on its own. So like the Madrid here, so without associated to the span, you still know where Madrid is. So basically the corpus, like the ARRAU series, so we like annotate both the kind of like lexicon and also referential bridges. So two types of them, and the other corpus such as IS-Note, Bash only annotated the referential ones. And the second challenge is like it's also under-resourced, although it's slightly more than the Split-antecedent, but still like the largest corpus, we only have like 3K examples of the bridging. So what we did is we come up with a multitask learning framework. So we train the bridging reference together with normal like the Coreference, and use a multitask learning architecture. And so that we share some of the feed-forward neural network as well as mention representations. In that way, the bridging, like the performance can be largely improved. So we try to like select the best settings. So like how many layers of the feed-forward neural network and also the embeddings we need to share. And then secondly, we also did some undersampling on the Coreference, because the Coreference is much more than the bridging. So we did some undersampling on the dataset and found additional improvement can be achieved by that. So we first tested on the 6 different corpus. So I guess this is the first system, so which is tested on all the different annotation scheme and different settings and so on. And our system achieved the best result on 5 of them. And as well as if we tested on the full bridging, our system always achieved the best result on all of the 6 corpus we tested. So another thing we did is like develop the universal Anaphora score, which has been used in recent Cody Quark share task. The score it can so it takes like UA CONLL-U-Plus. So Mesmo is that name. So the CONLL-U-Plus now. So I saw that previously it's expanded or something. So the universal Anaphora in the CONLL-U-Plus format. It's basically it has annotations for the like the identities, bridgings, discourse, axes, and other things as well. So the first few columns is just basically like the universal dependency columns. So it's kind of like compatible to the universal dependencies. And what the score can do is like we have a few different like the evaluation methods. So we can evaluate like the Coreference relation only, which means basically only the single antecedent part of the kind of like evaluation. So it's similar to the CONLL 2012 scholars in that way. And we also have the another evaluation method trying to evaluate all the Coreference relations, include the Split-antecedent and Singletons. And we can also evaluate all the markables. Basically, which also include the non-reference and the bridgings as well. And we also have the ways to evaluate the discourse axis, or if someone only interested in the Split-antecedent, we can also give the alignment scores for the Split-antecedent. And so the system also can do like some mean span evaluation, so include the mean span as well. So I think that's all for my talk. Oh, by the way, so if you are interested, so you can find our code and pre-trained modules either on my own GitHub page or on the DALI page as well. Yeah, thank you.